Students, up to this we have seen about the gravitational force, characteristics of gravitational force, how this gravitational force exerts, and we have found out the magnitude of this gravitational force between any two objects. Say suppose a body of mass small m, exerts gravitational force on another body of mass capital M, then the gravitational force exerted by body or a point mass small m on the capital M is equal to F is equal to G m upon r square, where r is the distance between these two objects. See, this is the line joining the two, center to center distance is r, with which these two bodies are separated. Then the gravitational force exerted by one on the other is G upon r square. Up to this we know. Now from this formula we can find out the gravitational force exerted on a point mass of mass m by the earth. What? By the earth. So here we can consider earth as a extended body. Previously we have also discussed that how to find out the gravitational force on a point mass which is lying outside an extended body. मागच्या व्हिडिओमध्ये आपण बघितलं, सपोज the body is lying outside, means here or out of the extended body, then what we can, like earth, then what we consider is the whole mass of this extended body is concentrated at the center of this body, and from this, the wherever the point mass be, we can find out the gravitational force exerted on this point mass by the extended body using this formula of gravitation, right? So now we will find out here, say m is the mass of a point mass of a body on which earth is exerting gravitational force. Then again what will be the formula to calculate this is nothing but gravitational force exerted on a point mass m due to earth, that is an extended body which is separated by a distance, say suppose r, means square of the distance. What does it mean? It means that suppose the extended body is lying, say suppose somewhere here the extended this body is lying, the body of mass small m may lie here, which is at a distance of small r from the center of the earth. Fine. Therefore, this is what the magnitude of gravitational force exerted on a point mass m due to earth, where m is the mass of the earth, and this mass is at a distance of small r from the center of the earth. From this formula, if we want to find out what is about the acceleration felt by this point object of mass m due to earth, that can be found out using Newton's second law. Newton's second law, this Newton's second law, you know that F is equal to mass into acceleration, isn't it? Force is equal to mass into acceleration. Then by using this formula, if F is the gravitational force between the point mass and the earth, then what is the acceleration felt? Acceleration, that we call it as again acceleration due to earth on this body, that is this body is felt acceleration and thereby it will fall on the surface of earth. It is attracted towards the earth. This acceleration produced, that we call it as g or we will find it out first of all and then write down. So this acceleration due to earth on the point mass m is equal to acceleration is equal to what is acceleration? Force divided by mass. Using this Newton's second formula, Newton's second law, we can find out F is equal to ma. This means A is equal to F by m. Which force is acting between this point mass and earth? Is nothing but the gravitational force. So we can write here gravitational force as Gmm divided by r square, and divided by m means 1 divided by m, and that is nothing but, or which is equivalent to, this acceleration due to earth is equal to g. See here, get cancelled. We have gm upon r square. Fine. Or we can write it as, suppose the object is situated on the surface of R. It means the distance between the center of the earth and the point mass is nothing but equal to the radius of the earth. It is nothing but the radius of earth. If it is situated, point mass is situated on the surface of earth, then they are at a distance equal to radius of earth. Thereby we can write here as a gm upon capital R square, which is nothing but the, we can write as small g. This acceleration due to gravity felt by the object of mass small m is equivalent to gm upon r square, that we have derived here. From this formula we can conclude that acceleration due to gravity by the earth only depends upon the properties of the planet. Like say now we have considered as a earth, that is mass of the, see here g is constant, having a constant value which is a universal constant. M is the mass of earth and r is the radius of earth. It means acceleration felt by the object due to earth is independent of what? Independent of mass of the object. It means suppose mass may be small m or very huge body, whatever may be the masses of the object, they get accelerated with the same acceleration due to gravity, that is equal to gm upon r. And from this, previously in the previous video we have discussed about the Galileo has demonstrated one thing, that any two objects which are of different masses, if they are dropped from the same height, they will reach the ground with the same, after the same time. It means they are dropping with the, they are felt with the same acceleration. That is what proved here with this formula, that is g is independent of mass of the, whatever huge body may be there, a body of very small mass may be there, both get attracted towards the earth with the same acceleration, and this acceleration is nothing but acceleration due to gravity. Fine. From this we can find out, from this formula we can find out the mass of the earth. See how, say g is having value. Suppose here we have considered the body of mass m is situated on the surface of earth, then at pole the value of g, we know it is 9.81 meter per second square. Radius of the earth is equal to, what is radius of earth? Is equal to 6.4 into 10 to the power 6 meter. So honey, what is the more over here? G, that is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. If you substitute the values here, we can find out the mass of the earth as mass of earth is equal to, its formula is g r square divided by capital G. G into r square divided by capital G. What does it mean? Keep the values here. 9.81 into radius of earth is 6.4 into 10 to the power 6 and divided by g, that is 6.67 here square r square, then 10 raised to minus 11. If we calculate the whole thing, we have mass of earth is equal to exactly 5.97 into 10 to the power 24 kilogram, or we can say nearly 6 into 10 to the power 24 kilogram. This is how, this is mass of the planet, say earth. From this formula of acceleration, we can find out the acceleration on the surface of another planet, say moon or Jupiter, or wherever we can find out, because it is independent of the mass of the object and depends only on the properties of the planet, that is mass of the planet and the radius of planet. As we have seen that a point mass get attracted towards the earth by an acceleration, with acceleration due to gravity, that is g, that is it will fall on the surface of earth with this acceleration. Fine, that we have calculated. At the same time, according to the Newton's law of gravitation, that earth, because this gravitational force is, it is a mutual attractive force, therefore as the point mass get attracted towards the earth with an acceleration, that is acceleration due to gravity, at the same time earth of mass capital M also get attracted towards the body of mass M, then can it move towards the mass? No, we found that it is not possible. Why does this happen? Because see here, the acceleration of the earth, according to Newton's formula, we can write force divided by mass, that is mass of the body, means this is equal to gm upon r square. If we want to find out this acceleration towards the body, towards the earth, then it is equal to by 1 divided by m, therefore gm upon g small m upon r square. Whereas the acceleration felt by the body that we have calculated right now is gm upon r square. R is the distance between these two. Fine. Then this is what the acceleration felt by the body towards the earth. Acceleration felt by the earth towards the body is gm upon r square. If we take the ratio, that is A towards acceleration of the earth to the acceleration due to gravity felt by the body, then we have formula, that is small m. If we take the ratio, we have small m divided by capital M. If we take this ratio, it means small m is too much less than that of capital M. Mass of earth is too much greater than that of the point mass. It means that this ratio is very much less than 1, up to nearly equal to, we can say, 0. Thereby earth will not get moved towards the body. It is stable, it is an extended body for this point object, and we found only the point object of mass small m, very small considered to the mass of the earth, will move or fall towards the earth with an acceleration, that is acceleration due to gravity, equals to gm upon r square. Right, up to this we have also deduced that this acceleration depends upon the properties of a planet. Then if we want to find out the acceleration of the moon, if we find out the acceleration of the moon, then what should be the formula? G for moon is equal to G into mass of moon divided by radius of the moon square of the radius of the moon square. From this formula for acceleration, because it depends not only on the body, only on the properties of planet. And thereby, suppose this is acceleration towards Earth, then this should be the mass of Earth, and say square of the radius of Earth. Now we are given, that is, say mass of moon, it is 1 by 80 times mass of Earth. Mass of moon is 1 by 80 times mass of Earth, and that of radius of moon is 1/4 to that of radius of Earth. Then can we find out the acceleration of the moon? Yes. So take this ratio and we have G for moon divided by G for Earth. It is equal to, take this ratio, Gmm upon R square divided by G for moon divided by R square. G will get cancelled. We have mass of moon divided by mass of Earth multiplied by, it is inversely proportional. So square of the radius of Earth divided by square of the radius of moon. Fine. Now see here, put the values. G for moon divided by G for Earth is equal to, what is about the mass of moon? Mass of moon is 1 by 80 times mass of Earth, right? Divided by mass of Earth as it is, multiplied by radius of Earth square divided by radius of moon square. What is it? It is equal to 1 divided by 4, means here 4 square and divided by radius of Earth square, because it is square. So 1 by 4 times means 16 Re square. So we have mass of Earth, mass of Earth get cancelled, radius of Earth, radius of square get cancelled. We have 16 divided by 18 means 1 by 5. So G for mass divided by G for Earth, we have it is equal to 1 by 5. But what we know about is G for moon, that is acceleration of the moon, is equal to, it is what, 9.81 in multiplied by means 1 by 5. So we have 1. We calculate this, we have Gm is equal to 9.81 divided by 5, which is nearly equal to 1.96 meter per second square. This is what the value of acceleration due to gravity on the surface of moon. Thus, for any planet, we can find out if we have the properties, that is radius and the mass of the planet, we can find out the acceleration on that due to that planet on any object, we can easily find it out.